Hello, I'm Dylan. I'm doing this part of the project, and I'm presenting on AlphaGeometry. AlphaGeometry is a way of solving geometry questions using AI and language models. Um, so how does AlphaGeometry work? AlphaGeometry works by combining traditional and novel AI methods in order to solve geometry problems. So first, let's start with the traditional standard method. It's called Wu's method. Essentially, how it works is we apply a set of deductive reasoning rules to different premises in order to draw more conclusions. And then we use these conclusions and more deductive rules in order to draw even more conclusions. And what we get is a large graph of different conclusions that we produce with these deductive rules. Eventually, we will find the end goal of the question, whether that's proving like an angle is 90 degrees or that's proving that two lines are adjacent. Um, but the problem here is that this graph can be really large and a very large search space to go through. Um, so there's a few things we can do. First is after we solve the problem, we're going to prune, which is where we only collect the conclusions that are relevant to solving our problem. But we actually want to increase the computational speed of this. In order to do this, we can involve a language model that is more direct and allows us to actually find the best solutions to our problem more rapidly without having to search through everything. So how it works is we combine the two by using the traditional method and then for lots of iterations until it gets stuck. And then we use the language model and then we use the traditional method and go back and forth. These two work in parallel. So how does the language model work? So first we need to generate a lot of synthetic data. We generate a lot of synthetic data by creating lots of problems and then creating the graphs for each of these problems and then having it predict the constructs required or the premises required to actually solve these problems. So here's an example of all of the constructs. So it's like we can build questions by combining these constructs in different ways. Here is, so what we can see is that we actually mask out different parts of the graph and we have the language model predict them. This allows us to solve our problem or to create training data for our language model. So we can see that there's tons of different problems, some of them a lot shorter and some of them a lot longer. This data is actually really high quality and represents a lot of the human generated questions. In fact, many of the human generated questions are actually in this data set. This data set is millions of questions. Yep. Um, so they use these millions of questions to train a traditional transformer model. It's 1,000 times smaller than GPT-4. It's able to be 1,000 times smaller because the data is very structured and there's not a lot of error in it. So this allows them to really efficiently train a model. Additionally, they use something called beam search, where they construct a lot of responses in parallel, and these responses in parallel are then ranked by how confident the model was in each token, by taking the sum of the log probabilities. This allows it to select the best answer from many answers. This greatly improves the results generated by the language model and ultimately by AlphaGeometry. Results. The end result is that AlphaGeometry is much better than previous traditional methods. You can see Wu's method just was able to solve 10 of 30 questions on the IMO, while this was able to solve 25, which is a massive improvement. This is almost ranking like a gold medalist, but hopefully in the near future, we will be able to improve upon this and actually beat out the gold medalist. Yeah, so there's a few key takeaways. First is that synthetic data works really well. One, because you can generate a lot of it, and two, because it's very structured and there's not a lot of error involved, which allows the language model easily to learn patterns. Additionally, The last thing that we learned is that traditional methods plus AI methods are very powerful. This is because AI is very powerful, but not super consistent, while traditional methods are not as powerful, but extremely consistent. So combining the two makes solutions that are far more effective. In conclusion, the AlphaGeometry is a highly effective tool for solving geometry questions and paves the path for other math solving AIs. And is a significant improvement over the previous iterations and also really shows the importance of synthetic data and combining traditional and AI methods.